Hello all, my name is Mason Hansey and I will be presenting on my genetic disorder, cystic fibrosis by Mason Hansey. So cystic fibrosis overview. Cystic fibrosis is a genetic disorder that causes issue within the lungs and digestive system in affected patients. It is extremely detrimental to the health of those afflicted and leads to issues that are ongoing for the duration of life and can only be mediated with therapies but not cured. There is no technical cure to cystic fibrosis, but it is helped through different immunotherapies. It leads to immunocompromised hosts who develop other conditions in other organs like the heart, liver, and even in the joints. As we go through this PowerPoint, we will break down various information on what makes this so deadly and the genetics behind cystic fibrosis. Okay, so cystic fibrosis description and major characteristics. As stated earlier, this disease affects the lungs by blocking the airways and allowing heavy mucus to stay within the lungs. This leads to higher rates of infections due to retained germs and the fact that it wears down tissue in the lungs. It also prevents proper nutrients from reaching the colon where they can be digested. This causes nutrient deficiency and ongoing health issues as the result. Molecular cause of the disorder. Cystic fibrosis is caused by mutations that arise in the CFTR gene. The specific mutation is called the F508del mutation and occurs in the 508th position in the chromosome itself. Its CDS length is around 4,443 NTs and has the length of approximately 1480 or 1,480 amino acids. There are 5 subdivisions of the CFTR mutation. These all deal with the processing, gating, insufficiency of protein production, and conduction. As stated before, these all occur in the F508del. Modes of inheritance. Cystic fibrosis is inherited as an autosomal recessive pattern. This is where copies of a gene have mutations in the cell. Parents can be carriers of the mutated gene and unknowingly pass it on to their children. There is a 25% chance that if both parents are carriers of the gene, their child will have cystic fibrosis. Pedigree, illustrating the inheritance pattern. This is the pedigree that I made earlier in the semester that showed the inheritance of the cystic fibrosis gene and who it would present in. As I said before, worth noting that if both parents are carriers of the gene, there's a 25% chance that their child will have it. It's almost guaranteed that one child will have it if they have 4 children. So that 25%, 1 in 4 children. You can see with this pedigree chart, I marked with the red corner who would have the cystic fibrosis and the probability of each couple's next child to have the mutation. Yeah, and then a chance, and then I also threw like the chance of the affliction with the disease if they had like or if they carried the gene, or if they, and like a combo of both. Wow, I fumbled through that. Options for genetic testing. Genetic testing options vary widely. It can be done through the Western blot assay, where we see the placement of a gene in the bands of the Golgi apparatus. Genetic testing is done post-birth and is part of a mandatory testing for diseases, so it's like a widespread check. Testing is mandatory in newborns, but if you think you are a carrier, you can pay for testing in a voluntary state. So basically, it's not required for older people, but newborns it is nowadays. ARUP Laboratories offers various types of CF genetic testing. Early detection can lead to better treatments or therapies in a child. This leads to lower mortality and a better prognosis in longer terms. Prevalence of cystic fibrosis. Cystic fibrosis is a relatively rare disease, roughly 70,000 to 100,000 cases worldwide. It affects 1 in 3,000 newborns on average. It is prevalent equally amongst the genders, but is seen primarily in either those with Northern European ancestry or those in areas of North Africa and the Middle East. Cystic fibrosis physical effects causes thick mucus buildup in the lungs that leads to low O2 sats and poor respiratory effort. Breakdown of tissues in the lungs leads to chronic issues such as coughing, wheezing, and inflammation. Chronic inflammation leads to weak lungs that become fibrotic and scarred. Insulin production is halted, and the blood sugar levels are also altered, which affects the pancreas and causes diabetes in some patients. Move myself. Okay. You can see right there in this picture that mucus is blocking the airway and leading to issues. Any airway that's blocked is going to have low O2 sats. History of CF. CF was first documented and described by medical professional Dr. Dorothy Anderson. You'll see right here. It was commonly known as mucoviscosis. High salt content led to the discovery of a mutation in the CFTR gene. Used to be seen as only a PEDS disease because the mortality rate was so high in children, and they didn't really have any treatments for it in the early years of this genetic disorder. Patients with CF now go on to live much longer and relatively less painful lives due to different treatments and immunotherapies that they can go through. Don't get me wrong, still a very bad genetic disorder disease to get, but it is more managed now than it used to be. Mutations and their impact. Mutations occur in position 508 in a chromosome. I touched on this. It's known as that F508del mutation. The CFTR protein aids in the maintenance of salt and water in the lungs and body. It also aids in the movement of chloride ions from inside of the cell to outside of a given cell. And that is basically it. That is a rough overview of cystic fibrosis. It's a pretty rare disease, but people go on to live good lives with proper treatment and have a much better prognosis than they once did. Yes, like I said, these are all my references gathered throughout the modules, and yeah, so hopefully that gives a good overview. Thank you. Bye.